Good morning, people. This is week 8, lecture 1, and I will be doing several problems for you. On the agenda, we have the completion of these two items, slider crank mechanism and a 4-bar linkage. Let me worry about 4-bar linkage later on and tell you what the slider crank actually looks like. It's actually a simplified version of a single cylinder engine. You can view this thing as a engine block. This is the piston, here is the connecting rod, and there is the crankshaft. So as the crankshaft turns, it moves the connecting rod, and the connecting rod makes this piston go up and down the engine block. Okay. First, I'm going to create the mechanism for you, and I'm going to use the magic wand, by the way. In other words, create the appropriate assembly constraints, and then using the magic wand automatically turn them into joints. It's not. It's kind of easy to see here that this actually is going to be traveling up and down. It's going to be a prismatic joint. Now, depending on how you do things, this can be a revolute joint or a cylindrical joint. Okay, so the way I'm going to do that for you today is I'm going to turn this thing into uh, a revolute joint. Okay, a revolute joint. So there's going to be a revolute here, a revolute there, and this one, it really doesn't have to be a revolute anymore. It can be cylindrical, or it can be the other way around. Okay, you can do it like that, or you can do it actually like I mentioned, right? After I do that, I'll come back and put some physics into it. For example, specify the speed of the crankshaft to be 1 rev per second, which is 60 degrees per second. Okay, let's go ahead and do that. There are some dimensions specified here. I'm going to try to stick to these dimensions, but that doesn't really change anything as far as being able to do that. Now, of course, the physics of wants to put the physics into the problem. The velocities and things like that, velocity and acceleration of different components depend on these dimensions. Okay, so the first thing I'm going to do is I'm going to save this product file. So file, save management, save as, desktop, a new folder, and the new folder is July. Okay, I believe that is July. That'll be July. No, wait a minute. That's going to be July. Today is what is today? This is June. Today is July. That'll be July 4. Okay, so July 4th. Happy July 4th. So, all right, I'll put it in July. In the July 4th folder. Good. Okay, let's do the base first. So insert a new part in there, and I'm going to call this thing the track. I think I called it the track, right? Or base. I called it the base actually. Properties. I'll call it the base. Base and base. All right. Let's make it. So on that vertical plane, I will sketch just so that the angle looks the way the view looks like the one that I showed you. Yeah, okay, I suppose we can do it like that. That's fine. So dimensions are 1 and 1. Exit padded by 10 inches. Okay, and I have a pin here on the side. Okay, on this side I will sketch. I'll put a little circle here. The diameter of this is 0.5, which is radius 0.25. Okay. I'm not going to bother making it centered or just leave it the way it is. Exit. Now pad it. It looks like I want a padding in that drawing. The padding is 0.5, I believe. 0.5. Okay, good. Let's go all the way to the top. Click on the floppy so that you saved it in that same folder. Let's do the crankshaft. So insert, a new part in there. Always say no. Change this thing to be crank, and crank. Say okay. Double click on this, and on that plane, I will sketch. Well, a circle this size, but the easiest way to do that is actually project that circle. There we are. And now we're going to make the rest of the crank. So the rest of the crank is very simple, actually. There's several ways of doing this thing. One of them, the easiest way, may be actually to do it with a elongated hole. I like that. Usually I draw a profile and then I clean it up. There we are. Okay, this is the lazy way of doing it. Now let's clean it up. So for example, I want this circle, control that circle to be concentric. There we are. And in the drawing, it seems that I'm indicating that the diameter of this circle is 0.75, although that really doesn't matter. But in case you want to put a diameter here, right there, cancel. This diameter, half of 0.75. So 0.75, that's actually radius divided by 2. Oh, what did I do? 0.75 divided by 2. Okay, good. Now, center to center, it seems that is 3.5, so I will make a dimension from here to there. 3.5. All right. And then finally, I'm gonna draw a circle here. You do it any way you want. This is how. Oh, wait a minute. Now, what is this? This is actually the connecting rod. It's not the crank. This is the connecting rod. I will fix that. Okay, so this thing is. I'll fix that. Okay, so this radius is 0.25. Okay, and let me pad this thing by 0.25. Exit and pad it by 0.25. Yeah, 0.25. And say okay. Now the only thing is that I didn't want this thing to be the crank. I want it to be the connecting rod. So I'm going to change it right here. Properties, conrod. Okay, and conrod. Okay, so let me go all the way to the top. Click on the floppy so that it's saved. All right, let me move these things away from each other. So I'm translating it that way. Okay, fine. Now I'm going to make the. Honestly, I don't know. Is this the. That was the crank. Ooh. All right, let's go back here. Right click properties, crank. Okay, and crank. So I was okay to begin with. Now my connecting rod is right here. So this is how I'm going to do that. All right, so maybe what I should do is on that face, let's go all the way to the top, insert a new part in there. Say no, that's going to be the Conrad properties, Conrad and Conrad. Okay, that's good. Let's make it. Double click. Now on that face, you do it any way you want. This is how I'm going to do that. On that face, I'm going to sketch a circle that size. So why don't I actually project that? I project that. There we are. You can see that right there. And to do the rest of this, once again, there are different ways of doing it. So let me hide that piece in the back. So let me do this once again, this thingy, the elongated hole. I'm going to clean it up. So this circle, control that circle. We want them to be concentric. Okay. That radius, we want it to be 0.75 divided by 2. Yep, divided by 2. I did the same mistake here. Let's try it again. 0.75 divided by 2. Ah, good. That's better. Now this length is, connecting rod length is 6.5, okay? So dimension, I dimension this. Can I dimension that? Yep, 6.5. 6.5. Okay. And I need a radius here, another circle at this end. Radius of 0.25 or diameter of 0.5, either way. That's the radius, so 0.25 will do. Okay. Now, exit. Exit. Now remember, my crank is actually in hiding. You can see it's back there, but I don't need it. That's okay. But what I'm going to show you here is that I want on this side to be a little pin sticking out. So of course, if I pat it now, there will be a hole here, okay? But I want it to be something sticking out. So here's what I'm going to do. You can do a multi-pat, for example. You select this, it says that there are 3 circles here. There is this one, which is the big one, the big boundary. So I want that thing to be 0.25. There is this one, which is the thing on that side. I want that thing to be a hole, so I just leave it as 0. And this one, I want it to stick out by some length. For example, I don't know, maybe a point, I can't remember. What is it that I have there? It says 0.35. Okay, fine. I'll make it, close that, here, 0.35, okay? Say okay. Now you can see. The only thing is that the direction of it was incorrect. So let me go back here. Let me go to that multipad. If it's too much of a hassle for you, you do it any other way that you feel comfortable with. There we are. Ooh, still doesn't look very good for me. So what I'm going to do is I'm going to go to that multipad. You know what? I'm going to do this. Oh, okay. So this is fine. Maybe I'll do it like that. Second limit. Okay, so I'll put down a 0.25. Oh, this is getting too much. So you know what? I'll put down 0.35. Let me go back here. tell you what. I'm going to leave this thing as 0.35 plus 0.25. That's 0.65. How about that? Look, there are many different ways of skinning a cat. You do it the way you want. Okay, if this is too much of a hassle, do it the way you want. Good. Go there. Click on the floppy. I regretted doing it this way. So let me see now what happened here. Click on the floppy. Impossible to save. Okay, already existing disk. Let's go here. Where are we now? Conrad, crank. Okay, that was a Conrad. Yep. So what is the issue here? Let me see for a second. I wonder what's going on here. File, save management, base is open. Conrad. Oh, there's two of them modified. Okay, so yeah. So let me do this. Save as Conrad. Correct. Because I kind of got distracted by that business and all right, let's find out what's going on here. All right, so let me go back to that folder. That folder was July, supposed to be July 4. This is the correct one. This one I don't want. I'm going to delete it actually. Okay, so go back here. No confusion. There shouldn't be any confusion. If you go to File, Save Management, yep. So this is the product. Save as. Let's make sure that we have saved everything. All right, good, good. Excellent. And there are things that like this that can happen to you on the test. Make sure that you master this process so that you feel comfortable. Okay, do it any way you want. All this happened because I got distracted by that multipath. All right. Okay, good. So let me go ahead up here, and we want now the what is it? The block, right? The piston. Let me hide. Let me bring it in the front so that we can see things. Now notice that it's not coming back. So if that happens to you, go to the tree and do it from the tree. Okay. All right. There we are. Let's separate these things. So I'm going to translate this thing in the y direction like that. All right. So here's the situation. This hole is going to go into that pin. This pin is going to go into that hole, and then we're going to do the block. Okay. So we're going to go up there, insert a new part. No, we're going to go here, call it the block. Or the piston if you want. Good, let's make it. It's very simple. So basically it is on that plane, I will sketch. Okay, and once again I didn't learn my lesson, so I'm going to make another multipath. How about that? Bad idea. But anyway, so let's put some dimensions here. Okay, and inside of that, I will draw a circle. If you want, you can center it, but it really doesn't matter here. This dimension, 0.25, and you know how to center it if needed, right? You should. Okay, exit. Now I'm going to do a multipath. So there's this guy, which is going to be 1 inches. And there's this guy, which is going to be, I don't know, one, maybe 2. Oh, 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 oh. Let's go back. Back. This one was 1, right? So it was supposed to be 1. Fine. This guy was supposed to be 2. All right. Maybe it's a little bit longer than what I wanted here in the drawing, but because this says a length of 0.75. Okay, if that is the case, let me go back here and, oops, no, in the multipath, 0.75 plus 1, so that makes it 1.75. It's a little bit short. Good. So let's go all the way to the top. Use the floppy. Save everything. Okay, so now we're going to do the assembly process. Okay, where are these things? First thing I'm going to do is to anchor the space. So click on the anchor, the space. Good. Then I'm going to put this crank on that pin. So coincidence between this axis and that axis, and coincidence, for example, between this plane and, if it makes you feel more comfortable, take that side. But with these arrows, you can actually control which side you want to take. So if you update, there we are. The only thing is that I would have preferred if, okay, so let me show you what I mean by controlling it. If you go to this last one and you flip on the arrow, flip the arrow, say okay and update, that's how it's going to look like. I did not have to be very fussy about which side I pick. You can control it with those arrows. Now, coincidence between that axis and this axis, and coincidence between this plane and that plane. Once again, if things don't look right, flip the arrows or go from same to opposite. Either way. Let's check this out first. It doesn't look good. Double click, flip the arrow, say okay, and update. That looks better. Okay. This is too long, I think, because notice that I didn't want it to be that long, so let me go ahead and change one of these dimensions. We can go actually to, this was what? This was the Conrad, right? So we go to the Conrad, and I believe it was this sketch, right? Yeah. Okay, so let me change this thing to maybe 5. Exit. Yeah, that's, ooh, this is because I did not, yeah, because of the way I did it. So let me go ahead back here and fix it. So let's go back to that sketch. Yeah. So I make this control that concentric. That's why it just stayed there. Yeah. That's a lot better. Very good. Now we're going to put this this block over there. So for the block, we say, let's go back all the way to the product. Coincidence between that face and that face. Okay, update. All right. And now coincidence. Here, let's do this. Coincidence between this edge and that edge. Update. Good. Now, if you wanted to end up on that, you just move it manually. So this is translation direction X. If it makes you feel better, go like that. Yeah, this, yeah, pretty good. Okay, now, as far as putting this hole on that pin, all you need is a revolute joint. You really don't need the, you need a cylindrical joint. You don't need the revolute. All you have to do is to say axis to axis, okay? So coincidence between this axis and that axis, and update there. Okay. First of all, let's save everything. How can we make sure that this is actually reasonable? So let's go to that move toolbar, manipulate, check this box, which means respect the constraints, and then let's do a rotation. This is a free rotation about that axis. Now things must move the way it is. If not, obviously the mechanism that you're going to do is not going to work for sure. But this is fine. This is fine. Okay. Let me say okay. So now we're done here. We're going to go to digital markup, DMU kinematics. Get the magic wand out. Where's the magic wand? Right here. Remember, these are the important, very important toolbar. Knowledge is later on for putting physics into it. So I'll put it just yeah, okay. Just leave it there. No problem. Okay, magic wand out. New mechanism. You can give it any name you want. Why don't I call this thing slider crank? This is just a name, slider crank. How about that? Okay, slider crank. Say okay. Auto create. Notice that the joints are created. There are 4 of them. Oops, not there. Let's go here. Mechanism, slider crank, degree of freedom is 1, 4 joints. Prismatic one is this block. Revolute between base and the crank. That's the revolute one. Revolute between conrod and the crank. That's this guy. And then the cylindrical one, because all we did, we made axis of this cylinder coincident with the axis of this hole. That's why it became cylindrical. Now, the 1 degree of freedom, because if you move the crank, the whole thing will move. So go to this crank and the base, make this thing angle driven, going from 0 to 360. We say okay, your best friend pops up. Let's do a simulation with command. Manually we do this. So let's check it out. Does it work? Yep, that works. That works. Good. I always reset. Now create a simulation. Slider crank. Remember, you drag this thing all the way to the end. Insert. Rewind. Change this thing to anything that you want. Anything but 1, not anything that you want. And then if you want this thing to go continuously, make sure that you use the correct loop change mode, which is arrow chasing each other, and just play. Good. So we have done a cartoon. You stop this, you rewind it, you say okay, the simulation has been created. Okay, good. Now, by the way, I want to find a trace of a point on this part. On this part is the connecting rod, okay? So I move to the part design by double clicking on that part, and I create a point anywhere I want on that surface. See, it's on a plane. I selected that plane. There we are. So this point must be on the connecting rod. If I want to get a trace, go back to the product meaning DMU. Now that you have actually created the simulation, you can go and compile it. You know how to compile? Same place that you did the simulation. There are other icons. You just click on that. And we want to generate a replay. I don't want to generate animation file, so that's good. And don't use a 1, use anything but 1, and then just play it. So what happens is that the replay has been created here. So you can show it to your friends, you can show it to your supervisor, etc. if you want. Good. Now we go and do a trace right there. You see that? Trace, click on it. It says element to trace out. For example, this point, that's the point that remember, this is the point that I created. And reference product is just the product, 26 points. So we say okay. There we are. Now make sure you save this. So file, save management, trace, save as in that same folder which was called July. I was going to call it July 4, but it's July. You say okay. Let me close that. Now I'm going to say insert existing component in there. It says which one? It's obviously the trace. There we are. Now if you play it, you see that that point, this point will actually go through that. If you replay it, right there. Okay, so let's do it continuously. Let me slow it. Oh, this is too fast. I don't want to do it like that. So rewind. Let me do that manually for you. So I go to simulation with command. There is the point that I created, and if you look at it, that point is right there, and it is going to move. That particular point is going to move on this trace. Reset. Now let's put some physics into the problem. So first of all, we save everything. Click on f of x. We don't want everything. We want the stuff only related to the mechanism. So click on the mechanism. Just these two. This is the angle of the crank. Add a formula equal to, if it's 1 cycle per second, or 2 pi radians per second, or 360 degrees per second, that's what I'm going to type. 360 DEG underscore S. So 360 degrees in 1 second times time, variable time is right here, but this is the name of it. The reason that actually came to be slider crank, because I renamed it from mechanism 1 to slider crank. If I had left that name as mechanism 1, this would have said slider. It would have said mechanism 1 can time. Say okay. Assuming that there are no syntax errors, etc. We go here, and now you go and do simulation with laws right there. I don't want to do it 10 seconds. I'll do it 2 seconds. You click on the 3 dots here, make this thing 2 seconds, and then play. There's physics here, but you may say that I don't believe you. How do I know it's physics? Just like the one that I did before. The only way to do that is actually to plot stuff. For example, first you need to go and create sensor right there. Speed, acceleration sensor. See that? Speed, acceleration sensor. You click on it. You give it a name. So reference product is that base. The point, for example, well, I can select this point. It's going to be the this point that I want to plot something about. You say okay. Notice that it has been created here, right there. Now you go through simulation with laws, and you say activate sensor. And what do I want? For example, I want the acceleration. Let's do two things. Let's take that point. Velocity of it and acceleration of it. Okay, so what does that mean? The magnitude. When I say the magnitude, means that I'm not going to give you x component or y component or z component. So velocity is this linear speed right there, linear speed. You turn into yes. And acceleration, the magnitude of it is just linear acceleration. Okay. Now there's one more thing that I'm going to ask for. You'll see why. I'm going to ask, for example, let me ask for one thing. See this uh, 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 slider crank? What is that? Slider crank. This one. Slider crank joined Revolut 2. Which one was the one that I had Revolut 2? Actually, it was, which one did I fix? Yeah, it was Revolut 2, okay? So I'm also going to ask for Revolut 2, which is the angle of that crank, okay? As a function of time, that angle will grow, correct? Okay, goes from this 0 to 360. Now, move this thing down and play it twice. When it's done, you go here, you say graphics. So let's check what things are. What is this yellow one? You click on the yellow one, it says the angle of the crank. It goes from 0, it goes 2 rounds, and it's going to be 720. You can see that. The angle grows and grows and grows. It traverses 720 degrees. If you go to this one, this is the acceleration. Remember, move these, zoom out. This is the acceleration of that point. Acceleration of that point, the red one. Acceleration of that point. And you can see that the magnitude of the acceleration, okay? Because it goes positive, negative, it slows down, it speeds up, but it's that red one. This guy is the speed of that point, okay? It's the green one. And once again, it's both positive and negative, but because I'm doing the magnitude, it just shows these things. Now remember, if I ask you to generate these plots, once you get this thing, you go and do print screen, and you create a, for example, a Word document. You can do it in Paint also, so paste it, home paste. Make sure that we can see the units here. Make sure we can see the numbers here, okay? And then save it. File, save as. In that folder, which was July, wherever I put my stuff, desktop, July, I'll call it my generated plots. Okay, so this thing is going to be in that folder. Now, suppose I want to, oh, I'm done with this. Suppose I want to generate the velocity of this point versus the acceleration of that point. So it's not versus time. Those plots that we just stored were versus time. So what you do is, first of all, you rewind. You clear the history. See that? You clear history tab, clear it. Okay, let's go back here. History tab, see history tab, clear it. So there's nothing there. And now you're going to say options. See that? Options right there. Customize plot, add, and go and pick the things that you want to plot one against the other one, assuming that you already asked for it. And I did ask for linear speed, and I asked for linear acceleration. Where's that? Linear speed. Where's the linear acceleration? Linear speed. And you say, okay, if you had not asked for these, you will not be able to do this. You say, okay. Okay. All right. And then you say, select it, close, and graph it. Ooh, I guess, yeah. Let's play it first. Let's play it. Let's play it. No problem. Play it. And now graph it. There we are. So this is the plot of acceleration versus speed. Magnitude of the acceleration versus magnitude of the speed. Notice that the vertical axis is inch per second squared, magnitude of the acceleration, and this is inch per second, magnitude. Now, again, print screen. If he had asked for this, you've got to give us that plot, and I will ask for it on the test. So, print screen. You go to that folder, you go to that file, or you can create another Word document, home, paste. There we are. Please make sure that you only give us the plots that we are asking for. If you give us the plot of something that I did not ask for, you will lose some marks, unfortunately, on it. Okay? Now, let's check it out. This is done. And rewind this thing. It's all done. I save everything because I'm going to do my second problem. Okay, let's check our folder here. That folder was right there. There is that generated plot that I asked you to do with Word document. You can double click on it. Then we can look at these and hopefully give you a perfect mark. Okay, good. So the second problem that I want to do is actually this one, which is called a 4-bar linkage. 4-bar linkages are very common in mechanical devices. For example, the wiper blade of a car is actually a 4-bar linkage. So if you say, where are the four? There's the motor, there is link 1, there is link 2, there is link 3, which the wiper is attached to it, and link 4 is that ground that are like you don't even have to make it because you know it's between two fixed points. So in a sense, it is a 4-bar linkage, but we don't have to make that fourth linkage because it's going from pivot point to pivot point, which is actually ground. Now, a fixed point, fixed member. Now, here's another example of 4-bar linkage. Link 1, link 2, link 3, link 4. Now, in order for a 4-bar linkage to have a member that you can attach, or you have a link that you can attach to a motor, it must have a one link that actually turns 360 degrees. And that condition is called the Grashof condition. So the smallest size plus the largest size must be less than or equal to the sum of the other two. If that is not true, if it's violated, then there is no member that goes completely 360 degrees. In this particular problem that I want to do, the smallest one is 10, the longest one is 26, the sum of them is 36, which is less than or equal to the sum of the other two pieces, is 36. So there will be a member that goes all the way around. So let me go ahead and make these things. Let me see that. Now I'm going to cheat, you know. No, I'm not going to cheat. Okay, let's not cheat. Let's go back here. Start with the product file. I want to make it exactly like what appears on that graph because that's really what you should do on the final exam. So insert a new part in there, right click. Oh, this is not the product. Control Z. I made a mistake here. Insert, new part in there. And I'm going to call this thing, I'll call it, okay, so properties. I'm going to call it the 18-inch. And there's two of them, both of them are in. So I'm going to call it 18-inch 1 because there are two links essentially that are 18 inches. 18-inch 1. That's very easy. Let's make it. Properties. Okay, 18 inches. Yeah. 1. I can use the same thing twice, but I'd rather not do that. So on that plane, I will sketch something which is something that is 18 inches. So how about using again this guy, elongate, not that, this. Okay, let's give some dimensions here. This is 18 inches. 18 inches. Good. Okay. Now it is true that I can make little holes here, you know, so that you feel better and make pins. But on purpose, I'm not going to do that. Okay? That's on purpose. Exit, pad it. How about by, I don't know, maybe 1 inch? Okay, so this is one member. You go all the way to the top because the other one, just like that, I can save it and then use it. Okay, but I'm not going to do that. So we say insert, a new part. Always say no. Right click properties. I'm going to call it 18 inches underscore 2. Same thing here. 18 inches underscore 2. You say okay. Let's go make it. What are you going to call this? No, 10. 18 inches. And this one 18 inches. Yeah. Sorry, this one. Okay. Wasting too much time here. Double click on this. Now, on that plane, I will sketch. Why don't I project exactly that thing? That face. Exit. Did I project it? Let me see for a second. Okay, let me actually undo this thing because I wanted to project the boundary of it. So on that face, I will sketch. I want to project that edge. Okay, no problem. This edge. Wasted too much time trying to save a few seconds. All right. Now, did I do this? Yeah. Exit. Hopefully, I don't have too many of these things. Pad it. 1 inches. Okay, so these are the 2 inches, two 18 inches. I'll go all the way to the top and make one that is 36. Okay, so 26. Insert a new part. Okay, is it there? Right click properties. 26 inches. This is the name of the part. Okay, 26 inches. Say okay. Properties. Inch. I'm becoming kind of sloppy here. Double click on this. On that plane, I will sketch. Let me do it on the other one so that I can see better. On that plane, I will sketch. Okay, so let me do another elongated hole like this. Fine. 36, 26, not 36. 26. Okay. Yeah, exit. Pad it. 1 inches. Good. Let me do one last one, which is 10 inches long. So all the way to the top. Notice that I'm not saving, taking my chances. Insert new part, 10 inches. Ten inch. Say okay. Go make it. on that plane. I will sketch. They didn't have to be on that plane. It's just that I decided to do it like that. Okay, so this is going to be 10. Ooh, 10, not 1. 10. Good. Exit. Pad it. Good. Go all the way to the top. All the way to the top. All right. So let me all the way to the top so that assembly design. This is not assembly design. See that? So I switch to assembly design. That's the digital markup workbench. Okay, so let me move these things around. So translate in the direction X, this guy and that guy and that guy. Okay, I'm making one of the 18 inches as the ground, or what I mean, anchor it. So use the anchor to do one of these. Now, coincidence between this axis and that axis, and coincidence between this plane and that plane, and update. There we are. Now, don't let it scare you because you can always rotate this. If it's bothering you, you can always rotate one of them. There. Okay, good. So coincidence between this axis and that axis. And now hang in there. Let's make sure that we get them the right ones. Oh, this 18 inches. Okay, so I'll put the 10 inches on the other side. Fine. Now cancel that. Cancel. Cancel. I'll put the 10 inches on this side. Okay, that's going to be my crank. So coincidence between this and that. Okay. And coincidence between this plane and that plane. Will I do it? Let's try it again. Coincidence between this plane and that plane. Update. Yeah, okay. Fine. Let's rotate this. All right. And now put the other guy in. So coincidence between this axis and that axis, and coincidence between this plane and that plane. Now this last one, I don't really need revolute. All I need is cylindrical, but even if you made revolute, it doesn't really matter. I'll make it cylindrical. Update. Good. Okay, so now we're going to go to the digital markup. Well, let's check it out first of all. Let's see, this box is checked. Can I rotate about this axis? Do you see that? This is a 4-bar linkage, okay? All right, one arm rotates continuously. That's this, at least one arm, okay? So cancel that. We're almost done. I think I went 4 minutes overboard, 4 or 5 minutes overboard, no problem. So now we go to digital markup, DMU kinematics, get the magic wand out, new mechanism, auto create. This is going to be a single degree of freedom mechanism. It should be 4 revolutes and oh, you know what? Let me undo this. I think I forgot to create my joints. A magic wand, new mechanism, Okay, auto create. Don't forget to do the auto create. So there are the joints. 3 revolutes, 1 cylindrical. So let's go to this guy, which is for 18-inch, and which one is this? Is it? Let me see. The one with the 10-inch one, right there. Which one is it? Let's check. Nope, not that one. The other guy. Just the one. Yep. Make this thing angle driven. 0 to 360. You say okay. Of course, mechanism can be simulated. Why don't we go and create a simulation and just run it? Drag it all the way to the end. Insert, rewind, and play it continuously. Anything but one, and play it. So this thing, this thing can be attached to a motor. This shorter one, okay. Let me do it like that so it's nice and easier for you to see. See that? Yeah. This is the link that's going to be connected to the motor. And the wiper can be attached, for example, to one of these things that's right. Now, you will be doing a problem like this for one of the homework problems. Okay? Good luck, folks.